Hey, how you doing, kids? I'm back. Doesn't seem like I was gone very long. At least for me it doesn't. Anyway, this is going to be the practice test number 4. What we are going to do is do parts, yes, 2 through 4. So this will be the longer of all those videos. All of this stuff can be found at www.nkinfinity.com. All right, you can't smell that. Just go over here to, where am I going? Let's go to here. What I got here, NK. There she is, kids. All right, just click on NK Infinity. Go to review. Click on review. There they are. There's all the stuff we're working on right now. I should be. Ooh, these are already done. Wait, these are already done. I think. What test am I working on? Test 4. Wait, hold on. I thought I did test 3 already. Didn't I do? Don't I? I thought those videos were up. Oh well. I got test 3 done. Apparently I don't have the links in there. I'll get them there, and test 4 will be finished now, and hopefully test 5 by the end of the day. All right, back to work. I don't know what that's, old Regents. All right, let's get going. Let's get going. There we go. All right, this is from an old Algebra 2 Regents, but it's just nothing more than, don't freak out. Don't freak out, okay? This is nothing more than product, which means you're going to just multiply. All right, 1/2 y squared times 12y is 6y cubed. 1/2 times 3/5 is plus 3/10 y squared. Negative 1/3 times 12 is minus 4y squared. And finally, negative 1/3 times 3/5 is minus 1/5 y. Now these two can be combined. This is 40 over 10. That's 4. It's actually minus 40. So I end up with 6y cubed minus 37 over 10y squared minus 1/5 y. And again, what I would do is take some number like 3.8, stow it into y, type this in, make sure you just put a time sign, type this in, and verify, yes, in fact, you do get the same answers. In a study of 82 players, so n equals 82, found the ages of players were normally distributed with a mean age of 17 and a standard deviation of 3 years. Determine if there were 18 video players in the study over the age of 20. So the first thing you ought to do is get a picture of what is going on. We draw our normal distribution curve, something like this. I'm going to put the information in there. 17, sigma is 3. Oh, this is just over the age of 20? Okay. I'm going to pretend like it's not that easy. Let's pretend like it's not that easy. There's 20. Okay. It's really just one standard deviation. So I want to know, are there 15 video game players? And so what I need to do is figure out what this probability is. So I can turn that into a z-score if I wanted to. 20 minus 17 over 3. Well, that's just 1. Obviously, it's 1 standard deviation. But I'm going to use my, so used TI Inspire. To use TI Inspire, normal CDF. And min is 20, max is infinity. Mu is 17, and you really can't have an infinity age, but for the calculator, that's what we're going to use. On sigma equals 3. So we'll go over to our calculator, and we'll use normal CDF, menu 552. This is going to be 20. Now, in order to get infinity, you just put a whole bunch of 9s in. 17, 3. 15.8. So the area of this, now this is the hard part most kids screw up, is 0.15865. 0.15865. Now if I was you, I would do also this. Norm CDF 20 infinity 17 3 equals 158655. 158655. But remember, this is just a percentage or a probability. What we got to do is got to say, oh, there's 82 players. We still have to take 82, multiply it by 0.158655, or in other words, go over to our calculator and hit times 82. This will tell us how many students. Oh, 13. So this is equal to 13.009. So what's the question? Determine if there were 15 video game players in the study over the age of 25. The answer is no. There were approximately 13 players over the age of 20. Done. Alrighty, that's it for that problem, kids. Alrighty, here we go. Solving an algebraic equation. So we want to get the weird thing alone. This is our weird thing. It's our odd thing. So we're going to bring this x over and subtract this x over. Now, I am not a fan of putting x second, so I will put it as this, negative x plus 7. Now we're going to square both sides in order to get rid of that radical. This just gives me x minus 5. Now remember, as soon as you square a radical, you could and probably will introduce extraneous solutions. Just be on the lookout for them. Be careful here. X plus 7, negative x plus 7. It's positive x squared minus 14x plus 49. Again, it's minus 7 and minus 7. Since this is positive, we'll bring everything to that side. I get 0 is equal to x squared minus 15x plus 54. And let's see what we got here. Ching, 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 ching. Factoring's pretty easy. Minus 6, minus 9. So I get my two answers of x equals 6 and x equals 9. Now there's a good chance one of these is an extraneous solution. So you need to check that. Store them in and check. I'm just going to do it real quick here. 6 minus 5 plus 6, does that equal 7? That's 1. Square root of 1 is 1, so 7 equals 7. I would do this on your calculator, not the way I'm doing it. Square root of 9 minus 5 plus 9, does that equal 7? This is 4. Square root of 4 is 2. 2 plus that is 11. 11 does not equal 7. So 9 apparently does not work. My only answer is, nice and professional looking, is choice 6. So moving on. Oh, I don't know why we put this one on here. This is nothing more than the state trying to mess with kids. Do you know what E is? Yeah, I know what E is. You come over here, it's E. There it is. There's the E button. So I come back over here and I say E, x is 3, natural log of 2. Right? I think the answer is 8. Should be 8. 3, natural log of 2, enter 8. I don't know why that was even any points or ever done on a test. It was stupid. So, moving on. F inverse. All right, so this question got people a lot. I think it's actually wrong on our answer key. So if you're looking at the answer key, I believe this is wrong. So the first thing we're going to do is write it as y equals x squared minus 6. And then the first step in taking an inverse is switch x and y. So you get x equals y squared minus 6. Okay. Add the 6. I get x plus 6 equals y squared. Now you need to take the square root of both sides. But you got to remember, when you introduce a square root, you got to put a plus or a minus. So I get y equals the square root plus or minus of x plus 6. But don't leave it like that. It should be written professionally. F of negative 1, or F inverse of x, is equal to plus or minus the square root of x plus 6. That would be the answer. Alrighty, here's another course 2 or algebra 2 or common back up. Here's another Algebra 2 trig question, but it holds true for Algebra 2 as well, so you might as well take a look at it. We're just going to factor this thing. First rule of factoring is GCF. So, looks like 3 goes in there, and also t to the 4th. So I'm left with 4t to the 4th minus 25. Well, these are both perfect squares, so those also can be factored. 3t to the 4th, 2t plus 5, 2t minus 5. Ka-chang, done. That's it. Problem's over with. Right? What do you mean it's wrong? Why is it wrong? Oh, you mean it makes a difference if I actually put a 2 here or a 2 here because this is a 4? Oh yeah, don't fall into that crap, right? You would have gotten a 1 out of 2 on that problem if you forgot those 2's. Makes a huge, huge, huge difference, right? Because this is 2t squared times 2t squared, which is 4t to the 4th. All right, now you got it right. So don't make that mistake. Hopefully you didn't. Woo! All right, let's see what we got here. Trying to figure out what color I want to use. All right, so the numerator is going to be 3x to the negative 4. I think the mailman just went by, or perhaps a leaf fell out of the tree, and that's why my dogs are barking like crazy. This is 2 to the negative 4, 2 to the negative 2. Let's just do that. X to the negative 6, y to the positive 14. Remember, when you have an exponent raised to an exponent, you multiply those exponents. Well, let's see what goes on. This thing has to come up because it's got a negative exponent. This thing has to come up because it's got a negative exponent. This thing has to go down because it's got a negative exponent. So let's rewrite this thing. 3 times 2 to the positive 2 because it came up. X to the positive 6 because those came up. Y to the 5th all over x to the 4th, y to the 14th. All right, so in the numerator, we've got, this is 3 times 4, which is 12. Let's see, the numerator has more x's. It's got 2 more, so that's going to be x squared. And get rid of 5 of those, and I end up with 9. Y to the 9th. Again, that can be checked using stowing a number in for x and y, typing in the original just as it appears, typing in my answer, and appears to be the same. Make it look all... Yeah, oh, that's pretty cool. Oh, that went away. Oh, we got another problem on this page. Use the appropriate procedure to show that that is a factor. Explain your answer. All right, there's 2 ways to do this. I'm going to do it the first way, which is a simple way of doing x minus 4, and I'm going to divide it into, just a little practice for you, 2x cubed minus 5x squared minus 11x minus 4. I'm going to divide into. So I put 2x squared, multiply by both. I get 2x cubed minus 8x squared. Don't forget, we're going to subtract, add. So I get 3x squared minus 11x. So plus 3x squared minus 12x. Don't forget, we're going to subtract. And I get x minus 4. And I put a plus 1 here at the end. X minus 4. And we're going to subtract, and we get 0. So do you see this word explain? Explain means use words to give me your answer. If you don't have words, it's not going to work. So since x minus 4 divides evenly into 2x cubed minus 5x squared minus 11x minus 4, we know x minus 4 is a factor of 2x cubed minus 5x squared minus 11x minus 4. Therefore, what's the question asking? Oh, that's it. That's it. Another way to do this, another way to solve this question is simply just to do this. Another way to solve this way. So that's method one. You just show that it evenly divides into, and you use words. Use words to explain. Now the other thing you could do is say if x minus 4 is a factor of x cubed, 2x cubed, let me write it down, minus 5x squared, minus 11x minus 4, then positive 4 must be a root or 0. When I evaluate f of positive 4, I got 0. Therefore, x plus 4, x minus 4 is a factor. You could also say by the remainder theorem, the remainder, and really this is it, the remainder theorem states and I just butchered that word, theorem states that if x minus 4 is a factor, then, this is the best way to say it, then f of 4 equals 0, since f of 4 equals 0, x minus 4 is a factor. Probably the best way to say it, by using the remainder theorem sounding all good. Or you can do long division. Either way is fine. Either way is fine. Most important thing is you have to use your word. Must say, got another one of these questions. Not a big fan of these questions. I just don't know why you would do this, but whatever. This is one of the state released questions, so we might as well go over it. So it says that Stevens Beverage Company is exploring or considering whether to will launch a product if at least 25% of its cola drinkers will buy the product. 50 cola drinkers were randomly selected to take a blind taste test, products A, B, and the new product. 9 out of the 50 participants preferred Stevens' new cola to product A and B. The company devised a simulation on the requirement that 25% of the colas drink the population. That's why I don't know why you would do this. Each dot in the graph show the proportion of people preferred to Stevens' product. Okay, so we ran a sample using 0.25 as ours, and we just asked. And we got a mean of this and a standard deviation of this. So the choice is, do you prefer Stephen? Yes or no. Now a no really is just they prefer one of those two, but it's either yes or no. So this is a proportion. Proportion. But they gave us the mean and standard deviation. So I think this one I actually have something hand typed up for you, but I'll try to do it for you evenly. Let's see. What do we got? The company wants to know. So what we need to do is come up with the margin of error for 95% confidence interval. Now remember, the state wants you to use 2 standard deviations. Yes, I know it's only 1.96 if your teacher taught it to you right, but we're going to use 2. So, so my margin of error is 2 times 0.062, which is equal to 0.124. So, does the sample proportion obtained from the blind taste test, 9 out of 50, fall within the margin of error? So let's do our, let's see what we got. We got 0.25 plus or minus 0.124. All right, so let's answer the question. We got our work there. Well, let's find that interval. What is that interval? Let's do that. I was going to go do that. That's what I was going to go do. 0.25 plus and 0.25 minus. So 0.126 to 0.374. 0.126 to 0.374. And what is 9 out of 50? Well, 9 out of 50 is really 18 out of 100, right? So that's 0.18. So the answer is yes. Now, this is our work, but we still got to justify our answer. So we've got some math to justify. We still got to come up with our answer. So, I'm going to look to see how I want to word this so I don't confuse you. So, yes, the interval, got to read my notes, see my chicken handwriting scratchings, the interval from 0.126 to 0.374, or in other words, 0.25 plus or minus 0.124, contains all plausible values. Well, I should say 95% contains 95% of all plausible proportions of people who prefer Stephen's new product. Something like that. The company decides to continue developing the product even though only 9 out of 50 participants preferred its brand of the Cola's taste test. Describe how the simulation data could be used to support this decision. So, the company has evidence that the population proportion could be 25%, as seen in the dot plot above. Based on the margin of error, we can expect to see quite a few sample proportions of 0.18 or less due to, now why would they be due to that? That's due to, remember, this is all sampling variability. So yeah, we're going to see a few of these that are going to be 0.18 or less due to sampling variability. Of course, I can't spell that. Variability. I somehow missed the L and the T. So variability. So given this result, given the results of this survey, of this simulation, simulation, there is not enough evidence to suggest that the true population proportion is not at least 0.25. So they should, what are we asking? Continue developing. Continue to develop. Man, sorry about that. That's a long question. Whew. So basically, in this very simple example, you find the margin of error by doing 2 times the standard deviation. We do 2 times the standard deviation. We come up with a margin of error. Our sample was within that 95% margin of error. And basically, because we can expect to see 0.18 periodically, due to sampling variability, then what the coming up with 9 out of 50 was not quite unexpected. So there's really not enough evidence to support that not doing it. Now, if you'd come up with something way outside of this, then you could say, well, maybe there's some evidence that this isn't a good example, a good idea. Anyway, let's move on. Holy mackerel, what the heck is this? Woo. Maybe I should have practiced this problem before doing it. I know I have an answer key, but let's see what we got here. Mortgage payment, how am I using that formula? Woo! I assume this is monthly payment. Yeah, see how it's monthly payment because we're taking the rate and dividing it by 12, and it's probably an interest rate of yearly interest rate. Annual interest rate. See right there? Annual interest rate of 0.04. So I'm going to put that. See, it says annual interest rate. So 0.048. And that's why we're dividing by 12. M is the number of monthly payments. Be careful, monthly payments. My guess is we're going to give it in years. Do we know how many years we're going to do this for? The bank's paying wants to borrow, so we want to borrow $120,000. They qualify for an interest rate of that. To algebraically determine the fewest number of whole years, the banks could do, if they want their monthly payment to be only $720. Oh, I put this in the wrong place. They want to borrow $120,000. They want their monthly payment to be $720, and that's P. No, that's M. Oh, okay. So 720 is equal to. Now we just got to put all this crap in here. Do it right. P is 120,000 times 0.048. Every time I draw a 4. I wanted to make sure I get this in here. 0.048 over 12, parentheses, 1 plus 0.04. I don't know what it is about 4s. They hate me. 48 over 12 to the n. Remember, this is number of months. So when we're done, we're going to end up with a lot of them. All over 1 plus 0.048 over 12 to the n minus 1. Man, that looks like a behemoth problem to solve. I think what I'm going to do is probably, we'll just start with something. Let's just start with multiplying these things out right here. Let's just clean this up a little bit. Let's just see what that is. So 120. You know what? I'm going to clear this out. I think. 120, 1, 2, 3, times 0.048 divided by 12. Let's just see what that is. Oh, that's nice. Oh, that's 480. So let's see. I got 720 is equal to 480. I want to figure out what that is too. So let's just figure out what that is. Let's just figure out what that is. That'll make my life a little bit easier. Just make it look a little bit nicer. So 1 plus 0.048 divided by 12. 1.044. So 1.004 to the n all over 1.004 to the n minus 1. Whew. All right, we're getting there. Now what? I'm going to guess we're going to have to cross multiply at some point, so we might as well cross multiply now. Remember, this is one big old thing here. You're going to multiply it by this. So I get 480 times 1.004 to the n is equal to 720 times 1. Well, I guess I can just leave it like that, right? 1.004 to the n minus 1. Man, crazy. So I'm going to distribute that 720. Let me get a smaller pen so it actually doesn't look so bad. So 480, 1.004 to the n equals 720 times 1.004 to the n. I should have kept that in parentheses. Minus 720. What the heck did I just write? All right, kiddies, notice that this thing and this thing are pretty much the same. So we're going to subtract 720. I say pretty much the same. What I should say as a math teacher is they are like or similar terms. They got the same crap. So let's see. I'm not dividing. I'm subtracting. So let's see. What is that? 480 minus 720. Negative 240. That's what I thought. Negative 240 times 1.004 to the n is equal to negative 720. Divide by negative 240. Divide by negative 240. We're almost there, kids. What is that, 3? I think that's 3. 1.004 n equals, I think that's 3. Must be 3. So now we're going to log this thing. It's all about that base, about that base, about that base. There's my base. It's all about that base. So we're going to do log of 1.004 of 3 is equal to n. So we'll grab that baby and put it in our calculator. Control log 1.004 of 3. 275.202. So n equals 275.202. Now remember, this is months, kids, months, not years. So in order to get by years, I just take that baby and divide it by 12. And I get 22.9. So n equals 22.9 years. So it would take 23 whole years. All right, moving on. Oh, got me a little snack. I'm getting hungry. Ooh, just dropped something. Oh, what a pig. All right, we got to solve these things. Ooh, this one looks pretty rough. That's what we got. I'm going to get rid of x's. Looks like x's are pretty good to get rid of. So what I'm going to do is I'm going to take these over here, and I want to get rid of the x's. So I'm going to multiply this first one through by negative 6. Now, when I do that, you're going to see what's going on. Oh, wait a second. Wait a second. I know why I was eating my cookie, because before I do that, what I want to do is I want to solve this thing. So I'm going to type this in. Menu, algebra, solve a system of linear equations, solve a system of linear equations. There's 3 equations. They did, in fact, call them x, y, and z. That's good. Let me just take a look. X plus 3y plus 5z equals 45. Next equation, 6x minus 3y. Ooh, wait, those y's. Oh, wait, the y's cancel really easy. You know what? Now that I look at it, I think I'm just going to cancel those y's. Plus 2z, you're probably all saying the same thing, right? Equals negative 10. And finally, negative 2x plus 3y plus 8z equals 72. I want the answers. I'm going to use my calculator to give me the answers. Negative 2, 4, and 7. So that they're in that order. X equals negative. Let's do this nice and neat. Let's see how neat I can be. Negative 2. Y equals 4. And z equals 7. So I already have the answers. By the way, that gives you no credit. However, let me go back to this. I'm looking now at these y's. These y's right down the middle can get rid of each other pretty nicely. So that's what I'm going to do. So let's rewrite it. So if I x plus 3y plus 5z equals 45. 6x minus 3y plus 2z, I don't know why my voice just went like that, and I'm going to add 7x, these go, plus 7z equals 35. I could actually, if I wanted to, divide all those by 7. That would make my life even easier. Now, I have no idea what just happened. All of a sudden, all of my writing just disappeared. That was the weirdest thing, and I couldn't even bring it back. So if it looks different, a little bit different here than it did about 30 seconds ago, it's because I had to retype it. All right, so now we're going to take these two and put them together. So we'll go 6x. Let's see if I can not do that again. 3y plus 2z equals negative 10, and negative 2x plus 3y plus 8z. The only thing that was left when I did that was the 8z. It's weird. Add these together, I get 4x, these go, plus 10z equals 62. All right, so now I got to put this equation and this equation together. Now, I'm writing way, way, way too large for this. So let me see if I can kind of make this smaller. And 4x plus 10z equals 62. So all I'm going to do is I'm going to multiply this one by 4 and this one by negative 7. Because that'll give me 28 and negative 28. By the way, I could have divided that whole first equation by 7 and make my life so much easier. 28x plus 28z equals 7140. Negative 28x minus 70z equals 42 and 14, 420, 14, negative 434. Yes, negative 434. So I'll get rid of these, and I get, and I can't do this easy math. Was that negative 42? Negative 32. 42? Negative 42. Z equals 174? 294. I wasn't even close. Divide by negative 42. Divided by negative 42. Let me just check that math. 140 minus 434. 140 minus 434. Negative 294. And then we'll divide by 42. Divide by negative 42. And I get 7. So Z equals 7. Hey, I got something. That's perfect. So now I'm going to bring that 7 and put it back into this equation. So 4x plus 10 times 7 equals 62. This is 70, so subtract 70, subtract 70. So I get 4x equals negative 8, so x equals negative 2. Yes. Finally, I'll grab any of the equations. I'll take the... I'm going to take this first equation because it's got all positives. So I'll do x plus 3y plus 5z equals 45. X is negative 2 plus 3y plus 5 times 7 equals 45. 5 times 7 is 35, minus 2 is 33, so 3y plus 33 equals 45. Subtract 33, I get 3y equals 12, or y equals 4. Is that the right answer? Yes! There we go, we got it. All right, that's it for that one. All righty then. This is a recursively defined sequence, and they want us to do it with an explicit formula. Now remember, the explicit formula is this just geometric formula, a sub n equals a sub 1 r to the n minus 1. Well, I already know what a sub 1 is. There's a sub 1. So I know a sub n is going to be x plus 1 times something to the n minus 1. It's just this thing that's going to be a little tricky to figure out. So, how do I find the common ratio? If I gave you the numbers 5, 25, 125, you'd say, oh, it's 25 divided by 5, or it's 125 divided by 25 to come up with that ratio. If I told you the terms were, 7x, no, why am I picking 7? 7 is the most obnoxious number in the world. 2x, 6x, 18x, 54x. All you got to do is take this, divide. Take this one and divide. Take this one and divide it. Every time you'll get 3. 6x divided by 2x is 3. 18x divided by 6x is 3. 54x divided by 18x is 3. So, in order to get the common ratio, you have to take what? You have to take... So the common ratio is equal to R2 divided by R1. Well, I know what R2 is. No, I know what R1 is. R1... you have to take a sub 2 and divide it by a sub 1. That's our common ratio, not ours. I know what a1 is. a1 is x plus 1. So really what I got to find is what is a sub 2. So let me just plug in a sub 2 here, and I get x times x plus 1. Oops. X times x plus 1. So that's a sub 2. All right, well, I'm going to go put that in my formula here. X times x plus 1. And if I do that, I see, wait a second, that cancels with that. So my common ratio is just x. So now I can come back to my formula and plug in x, and there is the answer to part A. So for what values of x would a sub n equal 0? Okay, so what do we got to do? We want to plug in 0 in for a sub n. So 0 is equal to x plus 1 times x to the n minus 1. How is that going to be equal to 0? Now, n has got to be greater than 1. What do we know here? So for what values of... So what do you think, kids? What do you think? All right, so sorry about that. I had to take a pause there because my answer key that I was given is not correct. See, it said that there is no solution, and there are. The only way that you're going to make... What values of x are going to make this thing equal to 0 is if this is going to be equal to 0, or if this equals 0. Okay, so all I got to do is say, okay, x plus 1 equals 0. If that's 0, this whole thing will be 0. So the answer is x equals negative 1. Or if this thing is equal to 0, x to the n minus 1, does that equal 0? Well, the only way that's going to be equal to 0 is if x equals 0. So in this case, the answers are 0 and 1, negative 1. Excuse me, 0 and negative 1. All right. So that ends that, and I will come back for, I think we got one last question. All right, we made it with some help. To number 37. It's getting cold. Can't drink it anymore. It's got to go. Anyway, let's talk about this. This is just a simple trig function. We're going to draft a simple cosine curve, and they're going to try to add all this complex stuff in. You know what's going on here, kids. This isn't that bad. Check this out. It says low tide is at 8:30 a.m. High tide is at 3 p.m. It says low tide is 12 inches, or high tide is 12 inches above, low tide is 12 inches below. Okay, and then they want us to create this function. So, and notice the other really important thing about this is T represents the hours since 8:30 a.m. So at 8:30 a.m., low tide. And then at 3 p.m., high tide. Right? So it says it's cyclical. So that means if this is going to happen, this is what, 6.5 hours? So in another 6.5 hours, let's go 9:30, we'll be back at low tide. I don't know if that's really how tides work, but it says up here it's cyclical, relatively constant cyclical tide thing. So we're going to just assume that. So how's this going to work? So think about what's going on here. It's going to start here at 8:30. It's going to start at low tide. Somewhere around 3, it's going to be up at high tide. And then somewhere back at 9, it's going to be low tide. So we got to start at a min and end at a min. So because of that, our equation, f of t, has to equal negative 12. Now, why is it negative 12? Well, because this is sea level. We're going up 12 and down 12, so that's our amplitude. Cosine b times t. Now, this is the thing I don't know what it is. I don't know what b is. But remember, this is b. And that stands for frequency, the number of complete full sine curves in 2 pi. So frequency is b. But remember, we have a formula for period. Remember, period, which is what they're asking for, right? Didn't they want us to graph one full period? One full cycle, right? We're going to graph one full cycle. So period is the time it takes to finish one full cycle. And that formula is 2 pi over b. Now, go back to what's going on here, kids, right? It's going to take 6 hours to get to high tide. It's going to take 6.5 hours to get to low tide. So this total time from beginning to end is 13 hours. So my period is going to be 13, is equal to 2 pi over b. Now, if I cross multiply and move, I get b is equal to 2 pi over 13. And I can put that right in here. 2 pi over 13. Now this, how accurate do we need to be? I don't know how accurate we need to be. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This will be 12, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, they weren't very nice, were they? So we will put our center line right here. This is going to represent sea level. There's our sea level. And sorry about the inaccurate drawings. All right, so this is going to have to represent 4, 8, 12, negative 4, negative 8, negative 12. All right, so how long is it going to take to finish one full cycle? It's going to take 13 hours. So I'm just going to make, well, there's probably 20 boxes across, so I'm just going to make every box 1, or go 2, 4, 6, 8, 10, 12, 14. All right, so let's see how things are going to go. We know that at time 0, we are at negative 12. at time 6.5, which is right here, we're going to be at positive 12. And at 13, we are going to be at negative 12. Now, we got to be careful with those. In between those two, we are going to have a 0. Well, that's at 3.25. And 3.25 here. So my curve is going to look something like this. Not the prettiest thing in the world, but there it is. That's our graph. Now, let's see what they ask. How much time we've been going for? I'm going to stop. I'll be right back. All right, finally. By the way, if you downloaded the answer key before I got a hold of this, it's not right at all. It was written backwards. I'm not sure what happened there. I'll have to blame my partner in crime. Maybe she was having a bad day. Hey, sorry, dude. Throw you right underneath the bus. There comes the bus. Threw it under the bus. Anyway, we'll fix it. It's not a big deal. That's what happens. Sometimes your brain gets a little cramped. Remember, see what's going on. At 8:30 a.m., we're at low tide. So at 3 p.m., what time was it? At 3 p.m., we're at high tide. So this whole time, it was increasing. Then at 3 p.m., for the next 6.5 hours, it was down to low tide. And this happened at what time? 6.5 hours later, that's 9:30. So now it's decreasing. So 7:30 p.m. would be during a decreasing time. At 9:30 p.m., it starts to go back up for another 6.5 hours, which will take you somewhere around 4 o'clock in the morning, 4 a.m. We're increasing. So, given this information, since the time interval from 3 o'clock to 9:30, the tide is decreasing. I would not choose 7:30. At 9:30 p.m. to 4 a.m., the tide is increasing. So I would choose to fish at 10:30 p.m. Catching. There she goes, kids. That's the answer to the question. That's all she wrote. Catch you on the flip side. Goodbye. Goodbye. Seriously, hit subscribe for me, will you please? Live scribes coming. Live streaming's coming. Goodbye.